An Introduction to the Theory of Automorphic Functions by Lester Ford. Chapter 1. Linear Transformations. Section 2. The Fixed Points of a Transformation. The points which remain unchanged under the transformation 1 are found by solving the equation z equal to the quantity az plus b divided by the quantity cz plus d, or cz squared plus the quantity d minus a times z minus b is equal to 0. Equation 7. If c is not equal to 0, the fixed points are chi1 equal to a minus d plus the square root of the quantity a minus d squared plus 4bc, all divided by 2c. And chi2 is equal to a minus d minus the square root of the quantity a minus d squared plus 4bc, all divided by 2c, equation 8. If c is equal to 0, the fixed points are chi1 equal to infinity, chi2 equal to b divided by the quantity d minus a, equation 9. There is but one fixed point if a minus d squared plus 4bc is equal to 0, or when ad minus bc equals 1, if a plus d squared equals 4. It is the point chi is equal to the quantity a minus d divided by 2c, equation 10. Equation 7 will have more than two roots only in the case it is identically satisfied. That is, if c equal to d minus a equals b equals 0. In this case, every point is unchanged in position. Theorem 4. The only linear transformation with more than two fixed points is the identical transformation z prime equal to z. By means of the last theorem, we are able to establish the following proposition. Theorem 5. There is one and only one linear transformation which transforms three distinct points z1, z2, z3 into three distinct points z1 prime, z2 prime, z3 prime. We shall prove first that there is not more than one such transformation. Let z prime equal the quantity az plus b divided by the quantity cz plus d, and z double prime equal to the quantity alpha z plus beta divided by the quantity gamma z plus delta. Be two transformations carrying z1, z2, z3 into z1 prime, z2 prime, z3 prime. Eliminating z, we get z double prime as a linear function of z prime. Z double prime equal to the quantity capital A z prime plus capital B divided by the quantity capital C z prime plus capital D. We know from theorems 1 and 3, without actually performing the elimination, that z double prime depends linearly upon z prime, for z is derived from z prime and z double prime from z by a linear transformation. When z equal to z1, z2, or z3, we have, by hypothesis, z double prime equal to z prime equal to z1 prime, z2 prime, or z3 prime. The transformation from z prime to z double prime has then three fixed points, z1 prime, z2 prime, z3 prime. And by Theorem 4, z double prime is equal to z prime. The two transformations are thus the same, which proves that there is not more than one transformation with the desired properties. That there is always one such transformation, we prove by actually setting it up. If none of the 6 values is infinite, consider the transformation defined by the quantity z prime minus z1 prime divided by the quantity z prime minus z2 prime times the quantity z3 prime minus z2 prime divided by the quantity z3 prime minus z1 prime equal to the quantity z minus z1 divided by the quantity z minus z2 times the quantity z3 minus z2 divided by the quantity z3 minus z1, equation 11. An equation which expresses the equality of the cross ratios z prime, z1 prime, z2 prime, z3 prime, and z1, z2, z3. This is of the form 1 when we solved for z prime in terms of z. It obviously transforms z1, z2, z3 into z1 prime, z2 prime, z3 prime. The equation 11 depends upon both variables if each set of 3 points is distinct. The determinant of the transformation then does not vanish. See the footnote in section 1. If z1 equals infinity, z2 equal infinity, or z3 equal infinity, it is necessary to replace the second member of equation 11 by the quantity z3 minus z2 divided by z minus z2, the quantity z minus z1 divided by the quantity z3 minus z1, or the quantity z minus z1 divided by the quantity z minus z2, respectively. And a similar change is necessary in the first member of an infinite value of z1 prime, z2 prime, or z3 prime. In any case, there is one transformation with the desired properties, and the theorem is established. Equation 11 is a convenient form for use in actually setting up the transformation carrying 3 given points into 3 given points. An Introduction to the Theory of Automorphic Functions. This book was written by Lester R. Ford, M.A., Harvard, lecturer in mathematics in the University of Edinburgh. It was published in 1915 by G. Bell & Sons Limited, London, and is now in the public domain. It is read by Jim Renhold with programming and illustrations by Jim Renhold in 2019. Thank you for listening.